Okay, Kiana, the first problem is a criminal wants to escape from the third-story window of a jail by going down a rope to the road below. Having taken high school physics, he thinks he can escape down the rope even though his mass is 75 kilograms and the rope can only support 65 kilograms without breaking. Explain how he can get down safely without breaking the rope. So, we've got two masses here. We've got the mass of the criminal and then the mass that the rope can handle. First, we're going to find the criminal's weight from the mass that was given. So that's going to be the mass of the criminal, 75 kilograms, times the acceleration of gravity. You know how to do that. You multiply it and get 735.75 newtons. And then second, we're going to want to find the weight that the rope can handle. And so, similar deal. It's going to be the mass of the rope, 65 kilograms, times gravity, and we get 637.65. So the rope can handle less weight than the criminal's weight. But we talked about this a couple of mornings ago. I don't know if you remember, about how whenever you've got weight, like in a free body diagram with the inclines, you've got a weight going straight down, and then we calculate the y component and the x component. Those components are always less than the actual weight. So we're going to use that principle here. So the next thing is we're going to draw a picture. And so let's say that this is the building. And so the green is where the rope would normally hang down, and that would be the criminal's weight, which is the heavier weight that the rope can't handle, so it'll break. But if the criminal pushes his leg out, or pushes his legs out at a certain angle, then we can get this side of the triangle, which would be the weight the rope can handle. And then you draw the line at the bottom, and it's a regular right triangle like you're used to. So I'm going to take this triangle and turn it this way. And so this would be a vector that is the criminal's weight, and this would be a vector that is the weight that the rope can handle, and then this would be the angle that we need to find, because we know this and we know this. So cosine is adjacent over hypotenuse, and our adjacent is the weight that the rope can handle, and our hypotenuse is the weight that the criminal is. So we fill those numbers in and we divide. And then in order to get the angle, if I remember correctly from your calculator, it's you hit second and then cosine to get the cosine with the -1. And then you put in the 0.867, and that should give you 30 degrees. So, if the criminal pushes his legs on the wall so that the rope is 30 degrees away, then the rope won't break because his component of weight will be less.